In this video, we're going to be evaluating partial derivatives at a given point. So now we have these three questions here, which of course we are finding partial derivatives, different ones, one with respect to y, to z, and to what, to x, like that. So now, how do we go about this question? So for part A, we have that f of x, y, and z, this is equal to the square root of x plus 2y plus 3z, and they're telling us to evaluate the partial derivative at that point, that is the partial derivative of y, then at the point that is 2, -1 and what, and 3, like this. So first of all, because I'm getting partial of y, it means that I have to what, find this partial of y, and I know that this partial of y is just can be written as the form like this. And this here is just me differentiating y, but treating all other variables in the function as constants. So you see here that I'm going to differentiate the outwards, the one which is out by chain rule, of course, and this here could be written as x plus 2y plus 3z to the power half. I differentiate the outward, meaning the power drops, and I'm going to have 1 there and 2 down. Then after it drops here, I subtract, it becomes a negative, and that will come down. So I have the square root coming down, so that will be x plus 2y plus 3z, like that. So this is how, of course, I know you know these differentiation techniques, but then I need to differentiate the inside function because it's chain rule, differentiate what's inside now with respect to y. So I differentiate, these are constant that you be treated as a constant. I differentiate u here. So differentiate u, I just remain with what? With 2 there. So I have 2. So just saying this is multiplying 2. Then this 2 and that 2 can divide. Then I just remain with 1 over the square root of x plus 2y plus 3z. So this is what I remain with. Now to find the exact point, I'm evaluating this at that's 2, -1, and what, and 3. So I'm gonna replace these in the what, in that function. Then I'll have x, that is 2, then plus 2 is what, -1 there. Then I have plus 3 is 3 there. Okay, so I'm going to have this is 1 over the square root. Then I have 2. 2 multiplied by -1 gives me -2. Then the 3 multiplied by 3 gives me 9. So this here, you readily see that's 0. Then you have 1 over root 9. And this 1 over root 9 just gives you 1 over 3. So the value at that given point is what? Is going to be 3. Okay, so let's do let's do the same for the next one. So I raise u. Okay. So what am I gonna have? So what the next one, you have f of x of y. The function has been given as sine. So you have sine z squared minus y squared plus x, like that. Then they're telling you to find f of z. Then that is at 1, 1, 0. So we first find that partial there. So how is that gonna be? So f z, differentiating this, so I differentiate the whole function, that is sine. So differentiate sine, I get cosine. Then I write what's there. So z squared minus 2 plus x. Then I differentiate the inside function. The inside function, of course, I treat u and u as a constant. Then I only consider the z, and differentiating the z squared, I get 2z, like that. Then this here, of course, writing it off nicely, is just 2z, then cos, I have z squared minus y squared plus what, plus x. Then now I am evaluating this at the point 1, 1, 0, and this here is going to be 2. The z is 0, so I get 0 here, cosine, then the z, of course, we said 0, minus the y is 1, and plus the what is going to be 1. Look at this, so this is 1 here. So look at this, just gonna be getting zeros everywhere. This 0 multiplies with all this, and this just becomes that this will be equal to what? To 0. Okay, we do the same now for the last one. Erasing you go, you go. Okay, what do I then have? So for the next one, we have f of x of y of z like this. And now they're telling us to find this here. We have tan inverse. So you have tan inverse, then tan inverse of what? Of x minus y over z what squared like that. Okay, then they're telling you to find f of x, then at the point that is 1 to negative 2. So how are you going to do this one? So meaning we first find f of x. So how do we do this one? So we see it's tan inverse. So meaning this is going to be over. And because here when I differentiate what's on top with respect to x, I just get 1. So I have 1 over. So on top is going to be 1. Then down there, I'm going to have 1 plus. I need to square this, which is there. So x minus y over z squared. Then I square the whole thing like that. Then, as I said, that we need to take the partial derivative. Okay, you need to take the partial derivative. It's not 1. The partial derivative of what's here. So I can write that as x over z squared minus the y over what z squared like that. So this could be written like this. So it will not be 1 because of how it's been written like this. So yeah, pardon me on that one at first. So differentiating this now with respect to x, you get 1 over what? Over z squared. So in short, what I'm saying is what you always do is you write the 1 over, then you write 1 plus, you square whatever is there. Then here you want to take the partial derivative of with respect to whatever you're being told of this here that remains. So, and I write it, let me replace it by that. So it is x over z squared minus y over what? Z squared like that. So getting that partial derivative, I'm going to have 1 over 1 plus. When I square this here, this I have x minus y squared, then over what? Z to the 4th like this. Then here, this just gives me 1 over what? Over Z squared when I differentiate that. So I can simplify this. So simplify this further on this other side here, on this left part here, simplify it by just multiplying by what? By a half. So I want to multiply not by half, but multiplying by z to the 4th. So z to the 4th, both in the numerator and in the denominator, I just get that would be z to the 4th. Then that would be z to the 4th. Then there, the z to the 4th is going to divide. So you just have x minus y squared, of course, multiplying by 1 over z squared, which is that there. Then from here, I can now, this can divide into that so that you remain with z squared on top. Then you have z to the 4th plus, then that is x minus y squared like that. So we found this here, which is our partial derivative, of course, with respect to x. Then they're telling us at the point, which is 1, 2, negative 2. So I replace these points in there. Then I'm going to have my z is just negative 2. So that's squared. Then here, negative 2 to the 4th. Then I have plus my x is 1. And then my y is 2, then squared. So this on top, I have negative 4 negative 2 squared gives me 4. Then negative 2 to the 4th just gives me what? 16. Then I have here, I subtract, I get a negative 1. Negative 1 squared is going to be positive 1. So this here then just gives me 1 over 17. That here is going to be my answer. All right. If you're new, remember to hit the subscribe button, and I'm going to see you in the next one.